All right, today we're going to do 4.5, which is inverses, multiplicative inverses, and we're also going to use them. We're going to use them to solve some equations. So I'm going to have you guys do these two. I know that this just asks, are these inverses, which is a yes or no question. You need to show me the work to show if they are or if they are not. Okay, you have to show me the work. Okay, so if you guys remember back to 150,000 years ago when you looked at the multiplicative inverse of numbers, so if I did the multiplicative inverse of 5, it's going to be 1 over 5. It's where you flip it. Really, it's what you multiply it by to get 1. It's kind of the same thing with matrices. In order for them to be inverses, you would multiply them together to equal, I'm going to say this is matrix A times matrix B. If you multiply them together and it gives you an identity matrix, then they are inverses. Okay, so what that means, if you guys remember, if I have a 2 by 2 matrix and I multiply it by another 2 by 2 matrix, in order for them to be inverses, it has to result in the identity matrix, which is this guy right here. So that's what I'm asking. So we're going to go through the process. So I'm going to multiply this row times this column. That's going to give me my first spot. 2 times 1 is 2. 0 times 4 is 0. So 2 plus 0 is 2. Then I'm going to multiply this row times this column. 2 times 7 is 14. 0 times 3 is 0. So this is 14. I'm going to multiply this row times this column. 0 times 1 is 0. 4 times 4 is 16. So 16. I'm going to multiply this row times this column. 0 times 7 is 0. 4 times 3 is 12. So it gave me this. This is not an identity matrix, so these are not inverses. Okay? So that's how you check if they are inverses. Now, what we're going to want to do the inverse is there's actually a formula to do it. So I'm going to label the matrix as A, B, C, D again. To find the inverse, you're going to do 1 over the determinant times the matrix D, A. These guys are switching spots. Negative B, negative C. These guys are switching signs. So you want to find the determinant of the original one. Another way you can think of it, I don't know if this really helps you, is you can think of it as 1 over A times D minus B times C, because that is the determinant, times D, negative B, negative C, and A. And another way to think of it, which I don't know if this helps you either, these are just 3 different ways to look at the same thing, is to think of the inverse as D over AD minus BC, negative C over AD minus BC, negative B over AD minus BC, and A over AD minus BC. I don't think that helps, but it's up to you, okay? So we're going to do a couple. So the first one I'm going to give you is 2, 1, 0, negative 1. So to do the determinant, I'm going to do A times D, which is 2 times negative 1, minus C times B, which is 0 times 1. So it's going to be negative 2 minus 0, which is negative 2. That's the determinant. If you remember in the equation, it's 1 over the determinant, so 1 over negative 2. These guys are going to switch places, and these guys are going to switch signs. We want to distribute this scalar factor on the outside. We do want to distribute that, so negative 1/2 times negative 1 is going to be 1/2. Negative 1/2 times 0 is going to be 0. Negative 1/2 times negative 1 is going to be 1/2. Negative 1/2 times 2 is going to be negative 1. So this is the inverse matrix of this guy up here. Okay? Really, that's it for inverses. You're just looking at switching your A and your D and switching the sign on your B and your C. And then you need to remember to do 1 over the determinant of the original matrix, which we already did determinants, so that should make sense. Now solving them, if you think about how you're going to solve something, if I have 7x equals 14, I solve this by dividing by 7. But really what I'm doing is multiplying by the inverse of 1 over 7, which cancels this out and leaves me with just x. And whatever I do to one side, I have to do to the other. So this is going to give me 2. Well, the same thing is true when we have an equation in matrices. So if it gives me an equation that says 2x plus 3y equals 14, x minus y equals 7. Let's say that it tells me this, okay? I'm going to write the matrix equation, which is 2, 3, 1, negative 1 times xy equals 14 over 7. Well, remember, if I multiply this by the inverse of this, they're going to cancel out, and I'm going to be left with just xy. So whatever the inverse of this is, if I multiply it by this side, I'm going to be left with just xy. Since I multiplied it by this side, I also have to multiply it by this side. So the inverse of this, I'm going to do the determinant. 2 times negative 1 is negative 2, minus 1 times 3 is 3, so that's negative 5. I do 1 over the determinant, and then these guys switch places, these guys switch signs. Now I'm going to distribute, so I'm going to get 1 over 5, 1 over 5, 3 over 5, and negative 2 over 5. This is the matrix that I'm going to multiply this side by. Since I'm multiplying it by this side, I also have to multiply it by this side, okay? So I want my resulting matrix to be 2 by 1, so that means this guy needs to come first. So I'm going to multiply this times this, not this times this. I hope that makes sense. So I'm going to multiply this times 14 over 7. This is a 2 by 2, and this is a 2 by 1. I can multiply them together. My resulting matrix is going to be a 2 by 1. So I'm going to multiply this row times this column. So 1/5 times 14 is going to be 14/5, plus 3/5 times 7 is going to be 21/5. Then I'm going to do this row times this column. So 1/5 times 14 is going to be 14/5. Negative 2/5 times 7 is going to be negative 14/5. And then I'm just going to combine like terms. So this is going to be 35 over 5, which is 7. And this is going to be 0 over 5, which is 0. So that means my solution is 7, 0. And that's all that we're doing right here. Oh, sorry, I went off the screen. That's all that we're doing right here to try to figure out the solution, okay? So you want to multiply the inverse times your solution set. So you got to find the inverse of this first matrix and then multiply it by your solution set matrix. And that gives you the answer. We'll get some practice in class. Don't forget to bring me those problems.